Pull,
Ready?
pull.
Sure you don't want to do it, Jeff? I got it. You set it down like that.
Yeah. We're at the portal of number 4 tunnel on the Superior vein. This material around us is what is called fault gouge. We'll see the footwall of the fault in the tunnel here about 200 feet in, and the hanging wall is way out that way someplace. The south end of the mountain just slid off. It rotated a little bit, and then it continues on to the southeast. But it's a very large fault, and this material is just when the mountain comes apart and slides, all this material is ground up, and it's called fault gouge. And we're going to be going through some of it, and we can see the footwall of the fault in this tunnel here. We'll go on in there. Okay, this is a fault, and the dip of it is like that. The strike of it is east and west. And when this fault happened millions of years ago, the south end of the mountain slid off that way. And all this material we've been walking through is called fault gouge. It's where it just gets ground up. And then the hanging wall of the fault is out that way quite a ways. And that end of the mountain slid down and turned a little bit to the southeast, and then it continued on. But this here is gabbro or greenstone, and the veins form in this rock. It's a very hard, dense rock, and the miners came during this tunnel about 1910, and they had to hand steel through this. And they probably only made a foot a day, because it's, hand sealing is really hard, and this is very hard rock. So anyway, but they drove this in, and we go in about 800 feet through this material, and then we hit the main structure. So we'll go on and on back in, okay? Slab here. That's, see, it's separated, and so the miners had a stool in here, and then years ago we put these rock bolts in to further strengthen it, and they're 5 feet long, so they go through that and they anchor into the roof above, and then we put the wire mesh to catch the small stuff. But it's, we just did it for safety. That thing weighs tons, you know, and so anyway, we reinforced it with these rock bolts. Each one of them is 5 feet long, and you have to drive them in with a jack leg. Okay, that's the ground support, method of ground support. All right, is it ready?
We're going.
Okay, we're 800 feet in from the portal, and this is where the miners hit the superior vein. The superior vein goes this way, and we came in on an angle, and this is where the miners found the superior fault. This is the footwall of the superior fault, and this is about vertical. It's 85 to 90 degrees, and this is clay, and you can see marks in the clay going this way. That's how the ground shifted right at this point. The ground went like that, or like that. But those slicken sides tell you the direction of the movement when the fall occurred. Now this is the footwall. The hanging wall is right over there, and this material overhead again is fault gouge. There's no ore in it. There's a little bit of quartz over here. You can see it here. See, that's quartz. And the gold comes in the quartz. And there wasn't enough here to mine, but they prospected a little bit. You know, went out on the wall. And, but that's what has the gold, but they had to go another 400 feet before they hit an ore chute, you know, in this fault structure.
So that's what they're after, right?
Yeah, yeah, the white stuff, that's quartz. And that is what has the gold in it. Not enough there to mine, it's too small. And this is an underground haul truck. It's a Getman KD2. It holds 2 yards, about 3 tons. And it has a forward and reverse lever on it. And there's a hydraulic dump on it when we get outside, you know, to dump it. So anyway, there's a loading station farther back where we would park in and then bring the muck out in a car and dump into this. But this would get us from the loading station to the portal about 1,000 feet.
Gasoline engine?
It's diesel. Diesel, and it's a little it's a 2-cylinder diesel. It's a Deutz, I think a model 714.
What year was it made?
Pardon?
How old?
How old? This was probably built in the 50s or 60s. I bought it up in Montana. They had 2 of them, and I bought both of them, and then I sold one. But anyway, this is how we get the ore out. There used to be rail in here all the way, and when we got here, the rail was just literally worn out.
Yeah,
And so we pulled it up and went with diesel equipment.
right. So not a lot of power, but geared low to move a heavy load.
Yeah, it goes real slow.
Yeah,
It'll climb right up the wall if you,
yeah.
I mean, it's
Good gears.
it's got a lot of torque. Okay, let's see. We'll go on back. Okay, this here, there was a chute here, you know, it came down and then parked our ore cars here and opened the chute, and that was all boarded off. And they dumped ore in this raise from number 3 tunnel. It's just 90 feet above us. And then they'd draw the ore out here, and they had like 5 or 6 ore cars pulled by a mule, and then they took the ore from here to the mill. This is mill level, this tunnel. And the track went right on over to the coarse ore bin in the mill, and then dump it in, and then the mill would pull the cars back in again. But this is like a transfer point. Anything mined on number 3 came down here, pulled out here to the mill. And like I said, it's 90 feet up to the next tunnel. You guys have been in that tunnel, and you saw the windlass in there and whatnot. That's on top of this raise. It's about 100 feet in from the portal. I know some of you have been in that tunnel up above. Now, the guys that mined this, they did it with hand steel, and they worked with candles. And see, they drilled a little hole out there, and then they put this in here, and they put their candle holder in there. You can either stick it in there or wedge it in, and the candle stick holder is here. And anyway, they work by candlelight. And there's a hole there, and then the next one is right here. And the guy that worked here, not here, it's farther up, but his name was Hap. And and he's got Hap written in this clay, and it was, let's see, 1/16/16. That's when he was there, 1916. They started the tunnel about 1910, I think.
They were still using hand drills and candles and tin, huh?
Yeah.
Pretty old style.
See, carbide lights came in about 1923,
Oh,
so they was using candles up till then. And
but
then
drilling was in the 1800s.
before that was oil lamps.
Rolling.
Okay. This is a lightweight jackleg here. This one is really heavy, and we used this one. And we drilled holes out here. See, you can see them. They're somewhere there. And this is a stoper. This is for drilling up holes. And it has a 30-inch feed. So you start with a 2-foot steel, and you run it in, and then you put in a 4-foot steel. This is a 4-foot steel. And 2 foots are there. So anyway, stopers are easy to drill with, and they're for drilling up holes. But this is a lightweight machine here. That one is a brute. It's too heavy. That weighs over 100 pounds, all of that stuff.
Wow.
This is a short leg for this machine, and that's when you're bolting and you need to get down low, you put that shorter leg on, because those bolts have to be driven in with the machine, with the jack leg. And this is the thing that drives those. They're actually split sets, but this is what drives them in. This is see, there's no, it won't rotate the way it's made.
So it just pounds them in.
Yeah, and you put, this goes against the end of the split set, and you just, and the jack leg, this actually is used in a jack leg. I just in there to keep it clean. All right. On a stoper, your air is in here, your water is in here, and you can adjust the water with the valve. And then this is your feed pressure. And you turn it like that, air will go down here and push your machine up. And then this is your throttle. And when you get it started, then you go on full throttle and you adjust your pressure so that your drill bit is held against the rock all the time. You don't want your machine to bounce on the drill. It's hard on the drill and slows you down, so you adjust the pressure so that you're steadily pushing. That bit's always against the rock, and if you get too much pressure, it'll slow down and lug, and you got to get experience. You know just how much feed to give it to get maximum speed. All right.
All right.
All oily now.
How many drill holes can you do out of a bit without sharpening or replacing?
Bits nowadays, they have a tungsten carbide insert, and see, this is tungsten carbide, and that would probably drill several hundred feet before you had to sharpen it. And then I've got a sharpener that will sharpen the carbide. It automatically puts that on it. And you have to watch, this is called the gauge here. And a bit will wear off on the corners, and then that will tend to stick it in the hole. So you have to grind this down so that this surface is like that all the time. Comes right up to a point there. That's the gauge. Then there's another type of bit we use. I don't know if I've got any here or not. But they're knockoff bits. Looks like all those are.
Same.
With a knockoff bit, it's a cross bit, and it has a short inserts in them, and you use them until the insert breaks or gets too dull, and then you knock them off and put another one on.
We've seen a lot of those in mines.
Yeah, that's there's an 11-degree taper on the end of the steel and an 11-degree taper in the bit. And you just put a bit on and pound it and make sure it won't come off and start drilling. This is the loading ramp where the muck goes from a mine car into that truck. And that truck is parked underneath where that mine car is. That ramp is in there because we had to move a heavy piece of a mucking machine out of here. And we used that to bring it down, the 12B mucking machine. That's why that stuff is there. I just never got it out of the way.
How much does a 12B weigh down?
4,400 pounds.
Wow.
They are heavy. Boy, they're sure good machines, though. They really muck fast. You can fill a car like that in a few minutes, you know. They dig into the muck pile, and then the bucket comes right over the top. And it comes right by your face. And if you're going fast, that bucket's going by you like that, you know. You gotta keep your head out of the way. So. Okay.
You make that look easy.
I've climbed hundreds and hundreds of feet of ladder. Can't do it much anymore.
It looked pretty good to us.
But this is a conventional mine car. It's an old antique one. It's riveted together. The later ones, they don't have any rivets in them. And it comes out loaded, and then there's a lock here, and you turn it like that, and it loosens that in front there.
We saw the dog move.
And it also unhooks it from the frame, so the miner can pick it up, see? If I picked it up all the way, the door would open. But it's locked to the frame by this lever. Okay. Yeah, you get it full of muck.
Okay, go ahead,
You
Jeff.
just don't want all your muck in the back, you know.
Right.
You want it
You
level.
gotta know how to balance
Yeah.
it.
Go ahead, Jeff, get a demo.
That's what I didn't
Doesn't matter
want.
if that falls out.
Yeah, no, we'll pull back. I'll push it back. So just the right amount and it flips open and you're down.
Yeah.
Yeah, that's not too bad.
Yeah, to shut that, you'll have to get
Yeah, I'll
that.
push it back.
Yeah, most mine cars, to hold this over, there's just a piece of wire attached there and a loop, and it goes over that. But this, I call a Cadillac of latches. That holds it in place, and that releases it. See, it releases it from the frame. At the same time, it opens the door. And I've never seen a latch like this on any other car. Cadillac design. This is called a split set. This particular one is 4 feet long. They make them up to 8 feet long, I think. And so when a miner uses one of these, he drills a hole that is slightly smaller than the OD of this. So it has to be driven in, and this collapses a little bit. And that's what holds it in. That it'll, the the rock grips against it.
By friction.
Yeah, by friction. And it'll grip it so hard that you could pull this off and it'd break off before that would come out.
Yeah.
And so, anyway, if a miner wants to support something up there, first he drills a hole, then he has to put a jack leg against this and drive it in. You saw that driver down there in the stoper. Anyway, that driver goes in here, and then the other end goes in the jack leg. And
So that would be your rock bolt or whatever to hold the wall in.
right.
Yeah, okay.
Yeah, them ones I showed you back there,
Yeah.
they were 5 feet long. They were like this. And we had to drive them all in with a jack leg. The guy helped me do it. And his name is Reuben. And, well, he just passed away a couple of years ago, but he was one of the top miners in the whole West.
Yeah.
Talk about strong. He started mining down in Grants, New Mexico when he was 17. And it was his goal to, there's a couple thousand men working there underground in the uranium mines. And I'm going to be the best jackleg operator in the whole district. And he was.
Yeah.
You know, in a year or two, he was the best one. No one could keep up with it.
There's a lot of competition in that. Those guys get
Yeah.
want to
Yeah,
up the other guy.
They want to drill more holes
Yeah.
or set more bolts than
Yeah.
anyone else. You know?
Right.
And they go for that. They get paid. You know, some mines they pay per bolt or per
Right.
foot of heading or whatever.
Right. More incentive that way
Yeah,
than
there's-
by the hour. Yeah.
Yeah, right.
Right.
Yeah, mines will normally have a base salary, you know. But if you want to make more money, you go for the incentives.
Yeah.
Because you get so much per foot, so much per bolt, and whatever.
Right.
Yeah. Yeah, most of the mines I've worked in have been that way. Yeah. Square set mines, they get an incentive so much per set, you know.
Oh, right.
Anyway,
Wow.
okay. Well, we're going back a little farther. This is a bit grinder for that chisel bit steel. You lay your steel right in there. When you turn the air on, the piston comes down here and locks it in place. And then you just go like this.
Just a spinning grinding stone in there.
Yeah, you have to use this green stone to cut carbide. It has to be a stone like that for the carbide. And
That whole thing is air run.
yeah, it's all air run, and water comes in here to keep the dust out, and then you pull it into the bit with this, see? You know, you keep pulling it in as you grind it down.
Those are expensive machines, aren't they?
Oh yeah, that thing costs a lot of money.
Would a miner sharpen his own bits, or is there a different operator guy that would do those separate?
Well, in the bigger companies, it's done in a shop.
Who makes this one, Don?
Atlas Copco.
It's an Atlas Copco.
Yeah, that's Swede. Atlas Copco makes a lot of machinery. That drill out there is an Atlas Copco. Now, see, these timbers are called stalls, and they're used to hold this up. And these stalls are made out of pinyon pine. They're still sound, but these are some posts that I cut, you know, to use for my use. This here is called a jackhammer, and you use that for drilling down holes. And that's what we were doing here in these winds is going down. That's a lot of work. You have to keep pulling them out of the hole to make sure your hole is open. kind of the mud. It'll wear you out. This is called a Jim Crow, and it's used for bending rail. This and this goes over the rail, and then the screw pushes against it, and it'll put a bend in it. So that's how miners make that turn, see? See, you run a Jim Crow along here and make a gradual turn. Now they found some ore here, and this is a raise. And the manway's on the right side. There was a ladder coming down here, and then the muck comes down inside of those boards. You have to keep the muck out of the manway, of course. So when they blast, they cover up the manway. The broken rock goes in that chute, and then they put a mine car here and pull the muck out right here. There's still not much vein here, see? And right here, the vein split. And one branch of it goes off to the northeast and just continues on north a little west. And there is some quartz in here, and this area goes 1/3 of an ounce, but it doesn't continue. And they went out that way a little bit to try and find a parallel vein. And then here's where they hit the ore chute that they mined. This is the south end of the south ore chute. And right up there is the stuff that has the gold in it. It's pretty narrow right there. But they used a method called cut and fill mining, and the waste stays in the stope, but they have to carry a cribbed raise up through the waste. It has to be cribbed solid all the way around. So the ore goes in here, the waste stays in the stope. This is a stope here. The waste is behind that timber, and the ore came down one of those, and there is the ore in the footwall. It's not very thick, and see all that stuff on the hanging wall, that's waste. So they didn't want to take the waste out of the mine, so they use it for fill. And this is what you call cut and fill mining.
Hey Don, I have a question about that.
Yeah.
So when they blast, they have to hand sort all of the muck.
Well, they might shoot the ore out first, and shoot that down on boards and canvas. They get that in one of these chutes, and then after they scrape it all off the boards and knock the boards off, then they roll up the canvas, shake the canvas into that, because the canvas has fine gold in it, and then they shoot down the waste, and they pack the waste around the cribbed raise. Each round they have to come up with the cribbing, another 4 feet, and then they put waste all the way around it. It's called cut and fill mining.
That's why there is not a huge waste rock pile out in front of this alley.
Right. Yeah, it's costs a lot of money to move waste around, and cut and fill mining is slower, but all your waste is still in the mine. They don't have to take it out. When they were drifting through here, all the waste went outside. See, above us there is waste. Behind them boards.
So this is just all loose gravel.
Yeah,
Blowing
above
up
us. Again, this is a crib. Goes up through it. See overhead,
Really long way down.
that's all for support. That's
These are like, oh,
cedar there, or juniper. This here is called spiling. And see, when they reopened this in the 40s, this was all caved in. So they had to spile their way back through all that caved rock. And they drive these in with a heavy double jack. They're just driven in by hand. The guy sure did work. They go ahead and they have to put in another cap and drive more and just spiled all the way through here. See, the vein is under our feet too, and it's going on down into the earth. We know it goes down another 400 or 500 feet. So there's ore below us. Now this is a good example of ore. That's the vein there. And the gold is in those iron bands, those red bands. And that's called banded quartz. And they call it California ribbon rock also. That's the same type of rock that's in the motherlode country, banded quartz. That right across there goes about 1 ounce per ton, which is good ore. They left that as a pillar to hold up this wall overhead. But above, they've mined over the top of that, see? But that's just a pillar. They don't like to leave ore like that, but for safety's sake, they left it so it wouldn't cave in on them. I see in this area, you don't see any quartz. It's kind of in and out. There's another area where you got a cribbed raise going up. They mined that out.
You can see the waste rock in there.
Yeah, originally, see, it's all quartz. It's ore,
Right.
but it's caved in up above, and now there's waste rock in there. Okay. This is called a winze. And a winze is a shaft, an underground shaft that a lot of times it's sunk right in the track, the veins going down that way. And this was started when we got here. They were down about 10 feet. And they had all of this in. That's the sinking bucket. And this is a method to make it dump. And the hoistman stands over here behind that hoist. And then he waits for a bell. Whoever's down below has to bell him. And this is the bell. And one bell means to raise, two bells lower, and three bells means man on, go slow. And then the muck went up and dumped right up there and came down into this chute. And then we draw it off here. We're down about 100 feet in this winze now. And this is where we pull the muck out, is right here.
You can see up there the. Okay. So then we'll come back here. We have some tools here. So come back here and we'll get a picture of this whole thing. Try and give it some perspective. So back here, that's the seat right there. This is where the hoist operator would sit. And of course this is all air powered. And here's the bell, hoist signal bell thing, and here's the count monitor.
Now that opening in there is a natural fault, and they drifted through there, and you know, nobody's been back in there. That's just how the rock is caved out, and it's just a fault that happened a long time ago, and it came up. We're in a fault here too. This fault's going north-south. That fault is east-west. And that fault ended right here. See, it doesn't go over under this wall. So it stopped when it got to this fault. But, you know, that, never been back in there, but I'm sure it goes a long ways. It's too dangerous to go in there. Now see, we're going north, we're still on the Superior Fault. They did some mining here.
A lot of wood in this mine.
Oh boy. Yeah. This is all Doug fir. They use 8x8s for posts and 8x8s for caps. Now this is another winch, and it goes down about 8 feet, and there's a quartz vein over there. The vein came right on here, and it was good ore, so they took this track up and they mined this out back to about that point, and they mined it out to there. And but you can look in here and see the face right here, and it's 30 inches of quartz. It goes a little over 1 ounce, so it's good ore. And then they went on ahead. Actually, they went ahead about another 400 or 500 feet, but the backlighting, which is this stuff, rotted out up there, and it caved in, and I've been trying to spile through it, and booked about 50 tons out of there, and it's still coming down, so I'm going to have to cement that loose muck, and it's the only way I can get through it. It's about 30 feet of muck in the track, and then it's open again. That's the end of the what we call the South Horse Chute. Then 300 feet of low grade, and then you hit the North Horse Chute. And the North Horse Chute is 100 feet long on the strike, and it goes all the way to the surface. It's been mined out. They mined 2 ounce ore out of that area back there. So we wanted to get back there, but I'll never make it. Someone will get there someday.